Hello everyone, this is Sophie Tan, and this is a video about atmosphere vocabulary words. So first word, atmosphere. So this is the gas or the air surrounding the earth, and the atmosphere helps protect living organisms by some layers, and also it contains like oxygen and nitrogen that is benefit for the earth. For example, the nitrogen helps transport the DNA, and also the atmosphere contains variable gas, and this kind of gas can vary due to human activities. And the second word, troposphere. Troposphere is the first layer of the atmosphere, or it is the lowest layer. Although troposphere is not very high, but most of the mass, about 75 to 80% of the atmosphere is in the troposphere. And also air, the temperature is warmest at the bottom of the troposphere, near the ground level, and air gets cooler when it rises. So, stratosphere. Stratosphere is the second layer, and this is above the stratosphere. And also we can see that there's a boundary between stratosphere and troposphere. That's called tropopause. And the stratosphere is very dry, so few clouds are formed in this layer. And this layer is the temperature raises as the height goes up, because the ozone layer is in the stratosphere. The ozone layer is a layer in Earth's atmosphere which contains relative high concentration of ozone. So what is ozone? Ozone is the layer, and it can absorb energy from the sun. So the sun radius will not hurt us and hurt other living organisms, since the UV, so above the stratosphere is the mesosphere. They also have a boundary that's called stratopause, and in the mesosphere, the temperature decreases with height throughout the mesosphere. The coolest temperature in Earth's atmosphere, and that's about negative 90%, 90 degrees Celsius. And actually, there is a few studies about this mesosphere, because the balloon cannot reach this mesosphere, and so thermosphere has very high temperature. It can reach about 500 degrees Celsius, so that's extremely hot. And this layer, the solar activity strongly influence the temperature, so the temperature is so hot. So the atmosphere, so atmospheric pressure. This is also related to the atmosphere. The definition of it is force per unit area exerted by the mass of the atmosphere as gravity pulls it to Earth. So we can look at this diagram. There are more molecules under and less molecules above. So we can see the higher has less pressure, and there is higher pressure under. For example, the Hawaii is located at the sea level. So when it compares to Denali, Alaska, so this place is located in North America, and there is a mountain called Mountain Maikili. So when it compares to Honolulu in Hawaii, so we can conclude that Honolulu has higher air atmospheric pressure because it is lower than the mountain. So relative humidity. Relative humidity is the amount of moisture in the air compared to what the air can hold at the temperature. What the air can't hold all the moisture, then it condenses. So basically, when we feel very hot, that's because the humidity is very high. And when it feels cooler than it really is, then the humidity is relatively lower. So the convection circulation. Convection circulation for the air, we can see from the graph. This circulates around the globe because of rotation of the Earth and the energy from the sun. Because the Earth is a sphere, so actually the equator is rotating faster than the pole. So this rotation is related to the shape of the Earth. And from this graph, we know that the hot air is less denser than the cold air, so it goes up because the less density. So when it goes up, it turns to cool air again and becomes denser. So the cool air goes up to the ground again, so it forms a circulation. There are three kinds of circulations in the Earth, and we'll look at it later. So weather. How is weather formed? Weather, according to this diagram, we can see that that's the daily weather that we can get. So the state of the air and atmosphere at a particular time and place, which means that weather is a short period of time to measure the temperature and the air and the atmosphere. So climate. Climate is different from weather because it is a relative long weather patterns. Like if we think of Africa, we believe that the climate is very hot. The warm front. The warm front is a transition zone from cold air to warm air. So the warm air will meet with the cold air, and the air will become warmer and more humid. So the warm air will raises above the cold air since it's less denser, and when it goes to the top of the cold air, it may form. And here's an example. We can see that before the warm front pass, the visibility is poor, and the pressure is usually falling, and the temperature is cold, slowly warming. And after passing, the temperature becomes warmer, and there's just a few clouds, and the pressure slightly raise, and we can see more clearly after the warm front pass. And the cold front. The cold front is defined as the transition zone where a cold air mass is replacing the warmer air mass. At this time, the warm front will go under the warm air because colder temperature has higher density. So the system, the high pressure system, this type of systems means that the pressure inside the system is higher than the pressure outside or the surrounding of the system. And this is associated with the fair weather because the high pressure, so the air sinks and it warms and is able to hold more water vapors. So in these systems, clouds tend to evaporate and the air becomes stable. So storms have a hard time to form in this system. And also the humidity is usually lower near or in the high pressure system. Because, for example, like deserts, most deserts have high pressure system since the drier air helps create the desert environment. And on the contrary, low pressure system has low pressure as its center than the area around it. So because the pressure is lower, the air tends to move above. So it sometimes forms clouds and often precipitation. And because of the way the earth spins, and so the winds of low pressure system, it swirl counterclockwise north of the equator and clockwise south of the equator. The temperature inversion. This is a bad issue in the Earth because a temperature inversion is a thin layer of the atmosphere where the normal decrease in temperature with height switches to temperature increasing in height. This is the normal situation that because warm air is less denser, so it's below the cold air. But sometimes, for example, if there is a very high mountain and the sunrise cannot reach the bottom of the land, then the cold air is staying below the warm air. Therefore, if there's some pollution here, then the pollution will track and goes back, so it forms very bad air in this area. So inversion layer. Inversion layer is a layer of the atmosphere in which there is a temperature inversion, with the layer tending to prevent the air below from rising, then traps any pollutants that are present. So that's the layer for the temperature inversion.